Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through how to work each of the problems on the Chapter 6 quiz review. My disclaimer as always, do not watch these videos and just copy down the answers. I would like for you guys to work the problems on your own and then come to the website and the videos to iron out any misunderstandings or errors that you might have made. So, keeping with my tradition of starting off with a Clemson reference here, I have a GIF, and this is the Clemson football team running down the hill in Death Valley, Clemson, South Carolina. The most awesome 60 seconds in college football. Of course, I'm sure a lot of you guys have your own opinions about that, but this is widely regarded as the best opening in college football. Pretty cool stuff. Alright, so without further ado, let's go ahead and jump right in. So, number one, Chapter 6, Similarity. We've got to make sure we get our units correct if we're trying to figure out how to calculate a ratio between two things, a comparison of two things by division. This first one, they want us to write a ratio of the first measurement to the second measurement. Now, if they don't say that, then we said in class that whatever they mention first, that's the guy that goes in the numerator. But they're telling us right out of the gate, just go ahead and write the ratio of the first guy to the second guy. But before I do anything with this ratio, I've got to make sure I'm comparing apples to apples and oranges to oranges. So I've got to make sure both of my units are in the same both of my quantities in the same unit. So I could either convert both of these to feet, or I could convert both of these to inches. Now if I want to convert 1 foot 8 inches to feet, that's going to be a little bit harder than just converting to inches. So I would suggest converting both of these to inches. So if you guys remember, this was one of the things that I said that was so very important when you're doing unit conversions. You just got to make sure that the correct units cancel. Yes, I know you guys know that there are 12 inches in a foot, but using dimensional analysis is something that's going to be very, very beneficial for you later on, especially in science classes, college courses, when you're maybe not sure exactly how to work the problem. If you just remember to make sure that the correct units cancel and you're left with the units that you want, then it's very, very difficult to get these kinds of problems wrong. So I need feet to cancel. I want to be left with inches. So where do feet need to go? The feet need to go on the bottom. So in 1 foot, there are 12 inches. And then notice that the feet cancel. And I got 4 times 12 gives me 48 inches. Okay. Now the second one, I also need to convert this to inches. Now that I got 1 foot and then 8 inches. So let's convert the feet to inches, and let's just add the 8 inches. So yes, I know you guys can do this in your head, but I'm going to write it out anyway just because I need you guys to understand how important this is. Alright, there are 12 inches and 1 foot. You got to get in the habit of making sure that those units cancel. Of course, 1 foot is 12 inches, and I'm just going to add the other 8 inches on top of that. So of course that gives me 20 inches. Okay, so now I'm comparing apples to apples, and now I can do my ratio of the first measurement to the second measurement. So my ratio of the height to the width, the height is going to be the 4 feet, which is the 48 inches. So 48 inches on top, and the width, of course, on the bottom, we converted that to inches, that's 20 inches. Okay, inches cancel, and I'm left with 48 over 20. Now yes, I do need to reduce my fractions. You can do that in your head, but as I showed you in class, we can use our trusty TI-84 graphing calculator to do the hard work for us. Let's type in 48 divided by 20. Press enter, I get some decimal. I don't care what that decimal is. I'm going to go to math, where my finger is, right below the green alpha button. Press math. And then up here, the option 1 is fraction, frac. I'm going to press fraction, I'm going to press enter twice. 1, 2. And it converts my fraction to the most simplified form, which is 12 over 5. So that's going to be a lot easier. Now, of course, simple fractions like 4 over 8, of course, you just do that in your head. That's 1/2. But higher numbers, just let the calculator reduce it for you. 12 over 5. Okay. So basically what that means is the height of the bonsai tree is 12/5 times as much as the width of the bonsai tree. Okay, Jessica is making a scale model of the entire Empire State Building. Her model will have a height of 16 centimeters. The actual height is about 448. What is the ratio of the height of the model to the height of the building? Okay, so once again, I got to compare apples to apples. All right, do you want to convert centimeters to meters or meters to centimeters? I would say it's probably easier to convert these meters to centimeters. Okay, so I'm going to start off with what I've been given. This is what I want to convert. I want to convert 448 meters. Okay, how many centimeters are in 1 meter? Century, century's 100 years, centimeter, 100. There are 100 centimeters per 1 meter. And now notice that tells me what I need to do because I've got meters on the bottom. The meters cancel. And now I know I need to multiply. If you can't remember, okay, do I divide by mass or divide by acceleration? Do I multiply by density? In your science classes, just make sure that those units cancel. And you're left with the units that you want. And now I just do 448 times 100, and that leaves me with this huge number, 44,800. I just add on 2 zeros right here. So the ratio of the height of the model to the height of the building. Now, how did I know to put the model on top? Well, they mention the model first. Model comes first, and then they mention the building. Whatever they mention first goes on top in the numerator. So that's just simply going to be 16 centimeters over the 44,800 number. Centimeters cancel, and I'm left with 16 over 44,800. 16 divided by 44,800. Press math, enter, enter, and it converts it. Actually, this one doesn't convert it to a fraction for me because it leaves it in scientific notation. So in this case, this probably is going to be one that you're going to need to do manually by hand. So let's see if the top and the bottom are divisible by 16. Let's divide 44,800 divided by 16, and that does go into it 2,800 times. So we're going to have to do this one the hard way because that's such a small number. So 16 goes into 44,800 2,800 times, so it's 1 over 2,800. But smaller fractions like that, you can just let your calculator do the work for you. And if you want to check that, I can just type in my calculator. You guys know I'm real big on checking. Let's divide 1 divided by 2,800. Oh look, guess what? We get that same small number, 3.57 times 10 to the negative 4th power. Okay, very, very small number. And I would expect that because we're talking about a model compared to the Empire State Building. I would expect a very, very small number. Okay, the measures of two supplementary angles are in the ratio of 4 to 5. So the way I taught you guys to do this, when you see the ratio with the colon, let's put a little x behind each of the numbers. What are the measurements, or what are the measures of the angles? All right, 4x and 5x, two supplementary angles. That means they add up to 180. So I'm simply going to take the 4x plus the 5x, and I'm going to set those equal to 180. So I get 9x is equal to 180. Let's divide both sides by 9, and x is equal to 20. So to find each of the angle measurements, I just take the 20 and I just plug it right back in to each of the x's here. So 4x is going to be 4 times 20. That's 80 degrees. 5x is 5 times 20, or 100 degrees. Okay, let's check our answer. Does 80 plus 100 equal 180? Yes, it does. So that's the answer to that question, 80 and 100 degrees. Okay, number 4, in the diagram, x over 15 equals y over 6. Okay, so remember with all these ratios, we said we can go left to right or right to left, bottom to top, top to bottom. I just can't crisscross. Okay, they have chosen to go right to left, which is fine. They chose to go x over 15 is the same as y over 6, which is fine. I could have gone left to right. 15 over x equals 6 over y. I could have gone top to bottom. 15 over 6 equals x over y. I could have gone bottom to top. 6 over 15 equals y over x. All of those proportions are the same thing. What I can't do is crisscross. I can't go left to right and then right to left. I can't go 6 over y equals x over 15. Okay, so what they're asking us here in this problem is if x over 15 equals y over 6, okay, right over left equals right over left, what is x over y? What is top over bottom? Okay, well, top over bottom's got to be the same as top over bottom. So x over y has got to be the same as 15 over 6. Okay, but look at what we did. This is the final answer, but look at what they did compared to the original proportion. The original proportion is x over 15 equals y over 6. So what did they do? What is the difference between the final answer and the original proportion? Didn't they just switch the y and the 15? In the original proportion, they put the y down here. The y is in the bottom left and the 15 up in the top right. Okay, so they just switch. One of our properties of proportion says I can switch these guys diagonally. Another property of our proportions says that we can flip these guys, the reciprocals, we can flip them vertically. 15 over x equals 6 over y. I just flip them vertically. And then all that means is top over bottom, or excuse me, 15 over x. So we went left over right equals left over right, which is what we just talked about just a minute ago. All right, so that's the answer. Top over bottom equals top over bottom. All right, you just got to make sure you're consistent with all the proportions. All right, number 5, how do you know when two polygons are similar? What must they have? They must have two things. The angles have to match, so the corresponding angles must be congruent. Put a little congruent symbol for sake of time. And also, the corresponding side lengths must be proportional. Okay, this question is on the quiz, guys. You got to know those two things. Corresponding angles must be congruent and the corresponding side lengths must be proportional. So in other words, the ratios of all the sides have to be the same. If I go 1 over 2, it's got to be 1 over 2, 1 over 2. All the side lengths have to be 1 over 2. If it's 4 over 3, then all the side lengths have to be 4 over 3, 4 over 3, 4 over 3. They all have to match to be similar. Give a real-life example as to when you might use a scale factor. I can think of all kinds of stuff. Maps. Okay, think about a map. Maybe not quite as much these days because now we have better technology with GPSs that do all that stuff for us. But back in the old school days, when you guys were just you guys weren't even born yet, but back in the old days, you had to do everything the hard way with a map. You had to look on the map and you would have a scale, and it would say that 1 inch is equal to 50 miles. Or something like that. And so you literally had to get out your map and you literally had to take a ruler and you had to measure on your map and say, okay, we're driving from Augusta to Atlanta. Okay, well here's an inch. Okay, well so it's 3 inches from Atlanta to Augusta. All right, so that means 3 times 50 is going to be 150 miles, and that tells you about how long it's going to take to get to your destination. So that's probably the first thing I think about when I think about an actual scale factor. Drawings, architecture, models, model airplane. So the model of the building was 1/2800th of the Empire State Building. That's a scale factor. Architecture, GPS, okay, any of that stuff would be good for using the scale factor. Anytime you're comparing something really, really small to something really, really big, you've got a scale factor. All right, so number 7. We've got triangle HJK is similar to triangle CND, and it's asking which pairs of angles are congruent. Guys, all you have to do is look at your similarity statement. You just need to match up the correct letters. Okay, H is in the first position, C is in the first position, so all the angles have to match up. So I'm going to say that angle H has got to be congruent to angle C. Angle J is in the middle spot, N is in the middle spot. That's that's congruent to angle N. And angle K is congruent to angle D. Just matching up the letters, third slot, third slot. Okay, that's the angles. Now, the second one says, what is the extended proportion for the ratios of the corresponding sides? Corresponding side lengths must be proportional with these ratios. Once again, I'm just going to match up the letters. The first 2 slots are H and J. Okay, so HJ, that side length over the ratio of that side over the side length of the second triangle, CN, okay, that ratio has got to be the same as the second and third slot. JK over the second, third slot, ND. And that ratio has to be the same as the first and the third slot, the last combination. HK divided by C and D. Guys, you could draw a picture if you wanted to, but really all you need to do is just look up here at the similarity statement to match these up. These 3 ratios have to be the same for these two triangles to be similar. Okay, number 8, continuing along with that same logic here. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So we need to go left to right to be consistent, especially when we're trying to determine what the scale factor is. Okay, so the first thing we got to do is make sure, are the corresponding angles, are they congruent? Okay, I've got a box and a box, single arc, double arc. What about this fourth angle? Well, in two triangles, we have something called the third angles theorem, which says if two angles of one triangle are congruent to two angles of another triangle, then the third angles obviously have to be congruent. Well, we don't really have a fourth angles theorem for quadrilaterals, but it still applies. If these three angles of this quadrilateral are all the same, don't all four angles of a quadrilateral have to equal 360? So whatever this fourth angle is, whatever that is, if these three angles of this quadrilateral are the same as these, then don't these fourth angles also have to be the same? So I'm going to put three little arcs down here for the second quadrilateral. Okay, so all the angles do match. And now I've got to figure out, do all of the side lengths match up? Okay, so do all the corresponding ratios, are they all equivalent? Okay, there's a couple of different ways you could do this. You could go big to big, little to little, as we'll see on the next couple of problems, or you could just simply look at the arcs that we have in our diagrams. So if I'm trying to figure out which one does 15 match up with, well, this 15 is between the box and the double. So I need to find the number over here that's between the box and the double, which in this case, here's the box and the double. That's going to match up with the 12. Okay, so I'm going to see, again, we're going to go left to right. We've got to be consistent. I want to see if 15 over 12, whatever that ratio is, okay, 15 over 12. Again, I can put that in my calculator if you don't want to do that in your head. 15 divided by 12, go math, press enter, enter. Okay, that's 5/4, all right? That means all of them have to be 5/4. I'm going to do these in different colors. Let's go blue down here. This 15, all right, that guy is between box and single. So which number is between box and single? That's this 12. Okay. Well, obviously 15 over 12, same exact thing, 5/4. Okay, so far so good. Let's go with hot pink. Let's go with the 10. The 10 is between the double arc and the triple arc that I made up. So which number is between the double and the triple? Okay, double, triple, that's going to match up with 8. So 10 over 8, divide the top and the bottom by 2, and yes, that's 5/4, so I don't need a calculator for that. And then the last one I'll do in beautiful orange color, and that's going to be the 7.5 is going to match up with the last number, which will be the 6. So what is 7.5 divided by 6? That's not going to be easy to do in your head, so we do need the calculator for that. 7.5 divided by 6. Go math, fraction, enter, enter. Oh, lo and behold, they're all 5/4. Okay, so we have, they all match. They're all 5/4. They all check. All the angles match up, so yes, these two polygons are similar. Okay, we got to read the question. Write a similarity statement. Okay, we can name this quadrilateral however we want to name it. I can go SNPO, I can go OSNP, I can go clockwise, counterclockwise, I can start wherever I want. I'll start up here in P and I'll go counterclockwise. So let's go with PN, I'm going PNSO. So if I choose to go that path, I've got to do the same thing down here. I'm starting with the double arc. Okay, I'm going double arc to the box. So over here, I've got to start with the double arc and then go to the box. So that would be KGAD. KGAD. And yours might look different than mine. I mean, there are lots of different acceptable combinations that would work. Let's answer the question though. It says give the scale factor. Again, we're going to go left to right for the scale factor. All these guys are 5/4. So the scale factor, I'll just write SF. The scale factor is 5/4 or 1.25. That means this triangle is 1.25 times bigger than this triangle. Okay. All right. Flip on over to the back. Are the two triangles similar? How do you know? Okay, so when we're trying to figure out two, now this is quadrilaterals. Okay, now this applies to any polygon, hexagon, heptagon, a million sides or whatever. When we have triangles, then we have a special set of rules for just the triangles. The possibilities could be angle, angle, similarity. That says that if two angles of one triangle match the other two angles of another one, that's all I need to know. They're similar. The other one we learned about was side, 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 squiggly, side, 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 similarity. And the third one we learned about was SAS, similarity. Okay, well, I don't know anything about any of the angles. Okay, so I'm going to scratch that out, scratch that out. So the only one that I can use is the SSS. So the question is, how do I figure out which numbers over here match the numbers over here to determine if all the ratios are the same? Well, let's just go big, big, middle, middle, little, little. So I will match up. I'll do this in different colors again. Let's go purple for the big numbers. 36 is the largest number on this triangle, so the biggest number over here would be 24. So let's check out that ratio. 36 divided by 24. Okay, calculator, 36 divided by 24. Go math, enter, enter. That's 3/2. Okay, it's easy. All right, the middle number, let's go with orange. 30 is the middle number, which the middle number over here, that's 20. 30 divided by 20, I don't need a calculator for that, the zeros just drop out. That's also 3/2. And let's go hot pink again. 12 is going to match up with 8. Once again, I got to go left to right. I got to be consistent. 12 over 8. I don't need a calculator for that. Divide the top and the bottom by 4. And what do you know? We get 3/2. So since all three of these ratios match up, yes, the two triangles are similar. Yes, by SSS similarity. And we have answered the question. That's how I know. All right, number 10, the flagpole problem. All right, so we got a flagpole that is 18 feet long. Rachel is 5 feet tall, and her shadow is 4 feet long. Guys, you got to draw a picture. Draw a picture for these problems. Got to draw a picture. Okay, so I will draw as best I can. I will draw a flagpole. Here's a flag. And here's the sun. So the sun is shining down. Whoops, you can't see that. Sun is shining down on this flagpole, and it's causing a shadow. So basically, this is forming a right triangle. Flagpole makes a right triangle with the ground, and I'm causing a shadow for the flagpole that's 18 feet long. At the same time, we've got Rachel over here. This is the best I can do, guys. I don't know. Here's some hair. I don't know. She's smiling. I'm an engineer. I can't draw. That's the best I got. At the same time, the sun is also shining down on Rachel, and that's causing a shadow that is 4 feet long. Okay. Well, Rachel is 5 feet tall. Okay, so I've got this triangle, her height, the ratio, since the sun is shining down on both of them at the same angle, obviously, then the ratio of Rachel's height over her shadow should be the same as the flagpole height of the flagpole shadow. And that's what they're asking for. What is the height of the flagpole? So they want to know x. Okay. Now once again, guys, there are lots of different ways you can set up this proportion. I like to be consistent and go left to right. So I'm going to go the height of the flagpole over Rachel's height, x over 5. If I go left to right, we've got to be consistent. That's got to be the same as 18 over 4. Okay, cross multiply. 4x is equal to 5 times 18 is 90. Divide both sides by 4. And I get x is equal to 22.5. 22.5 feet. Does that make sense? Do you buy that? Well, look, think about it logically. Common sense. Well, Rachel's height is 5 feet. Her shadow is 4 feet. So her height is just a little bit tall. Is just a little bit more than her shadow. Is 22.5? Is the flagpole height a little bit more than the shadow? Yeah, that makes sense. If I'd gotten a number that was less than the shadow, I'd say, wait a minute, that can't be, because Rachel's height is greater than her shadow. So you got to use that common sense logic. You know, does my answer make sense? Does it pass the laugh test? You know, kind of mentality every time you get an answer. All right, let's say we didn't go left to right. Let's say we went top to bottom. Let's see what would happen. The flagpole height of the flagpole shadow, x over 18, that would have to be the same as Rachel's height over Rachel's shadow. 5 over 4. When I cross multiply, I get 4x. Cross multiply, I get 90. Oh, look, it doesn't matter. I'll get the same answer either way I do it. The only way I can mess this type of problem up is if I go left to right. X over 15 equals right to left. 4 over 18. I can't do that. Okay. All right, so that's the flagpole problem. 22.5 feet for the flagpole. All right, number 11, are the triangles similar? And what is the similarity statement? So once again, I'm back to, for triangles, I got three different opportunities, three different options. Angle similarity, SSS similarity, SAS similarity. I only know one of the angles, so I can't do AA. And I don't have the third sides here. Technically, yes, technically I could use Pythagorean theorem and figure that out, but we haven't quite got there yet. So let's just go ahead and scratch that out. The only one I could possibly use is SAS. Side, angle, side, side, angle, side. So let's see if these ratios match up. Once again, I'm going to only have two numbers, so I'm just going to match big to big and little to little. So 12 is going to match up with the bigger number here, 4. Let's see if 12 over 4 divide, that's just 3, or 3 to 1, however you want to think about it. Is that going to be the same thing as the smaller number over here on the left over the smaller number over here? 8 over 3, that's obviously not 3, that's actually 2.7. Okay, so not similar, nope, the ratios don't match. 3 over 1 is not the same as 2.7, so no, they are not similar. Okay, number 12. These are the tricky ones. Similarity in right triangles. Okay, so it's asking us to write the similarity statement for all three of these triangles. Okay, so here's where we're going to use Papa, Mama, Baby. I'm going to do Papa triangle in purple. Okay, I would strongly suggest that you guys darken this in with your pencil, get some colored pencils, magic markers on the quiz and test to help you color code these things. We've got to redraw and separate out these triangles to have a chance to get this right, guys. Alright, so I'm going to have Papa triangle, Papa. The right angle is here. Now, normally it's pretty easy to figure out which is the short side, which is the long side. Just kind of visually, I know we're not really supposed to go based on our eyes here. I mean, that's about 1.5 centimeters. You know, this is about 2 centimeters. I mean, hopefully you can see visually that this is the shorter side. Okay, so the right angle for Papa, the right angle for the purple triangle is sitting right here at H. Okay, so H goes here. So if you can't figure out where the Y and the B go, this is just something, you know, I'm going to throw out there for you guys. Just throw in a number. Throw in an angle measurement. Let's just make up a number. Let's just put 30 degrees right here. Okay, if this is 30 degrees, and let's let all of our triangles, when we write them out, let's let all the 30-degree angles be over here. Okay, so I'll put the 30 degrees here, which means this has to be the Y, which means the B has to go up here. As long as I'm consistent with putting in a number here, then all of my triangles will be the same. They'll all be oriented correctly. Okay, or of course, like I just said, you can just say this is the shorter side, so the HB goes here, whichever you're more comfortable with. All right, so now let's go with Mama triangle. That's going to be the medium triangle. I'll do this in blue. And here is the blue box, the 90-degree angle for the Mama triangle. So Mama triangle is a little bit smaller. There's the 90-degree Mama triangle. All right, so now if this is why I like the idea of just kind of throwing in a number if you can't visually see this, which side is the short side. The box for the blue triangle, I just highlighted it, is right here at D. Okay, now where's the 30-degree angle? The 30-degree angle is the same for the purple angle as it is for the blue triangle, right? Okay, so they're both sharing this 30-degree angle. Okay, so there's the 30-degree angle, which means the Y for the blue triangle has to go right here. Okay, up at the top, of course, the last letter for the blue triangle will be the H. Okay, and then we have the baby triangle, which I'll do here in orange. Again, you guys, you don't have to put that 30-degree angle in there if that's confusing you. You don't have to do that. You can just do it visually like we did in class. For those of you who are not visual learners, maybe you like the idea of plugging in some random number to help you get oriented. If this is 30 degrees, and I'm looking at the purple triangle, Papa triangle. If this is 30 degrees and this is a 90-degree right angle, then this third angle has to be 60 degrees. Which means for the baby orange triangle, there's the right angle, that means the 30-degree angle for the orange triangle is up there at the top. Okay, So when I draw the baby triangle, here's the 30-degree angle. We got 30, 30, 30. Here, the 30-degree angle for the orange triangle is right there at the H. Okay, the box for the orange triangle is down here at D, because both of these angles have to be supplementary. They both have to add up to 180. So the box will be D for the baby triangle, and of course the third for the baby triangle, the third letter will be B. Okay, so let me go over that one more time. If you don't, guys, you do not have to use these little angle measurements that I've thrown in there. I've literally just made up a number off the top of my head. We don't know what those angles are. I just made up some numbers so I can orient these triangles correctly. You don't have to have that. You can just visually look and say, okay, this is the short side of the purple triangle. So here is HB. This will be HB. You could say this is the short side of the blue triangle. So that means HD has to be here, the short side. You can just visually look and say, okay, for the orange triangle, DB is the short side, so this will be DB. Okay, that's perfectly fine, however you want to do it. The whole point of doing all this stuff is so we can write a similarity statement. I'm going to choose to go BHY. I'm going to go top, bottom, right. Top, bottom, right. So my similarity statement will be triangle BHY is similar to triangle HDY is similar to triangle BDH. Okay, why are we learning all this stuff? Well, the chances of you having to split out and separate and redraw 3 triangles in your job and write a similarity statement is very close to 0. But this is an organizational, orientational, visualization skill that you're learning. Can you take something that's kind of complicated and reorganize it so that it's easy to make sense, so that you can answer a question? This is an actual skill. Okay, so kind of remember that as you're going through geometry. You're building a specific set of skills as you are learning these things. Okay. All right, again, your similarity statement might look different than mine. You could have gone backwards. You could have gone YHB is similar to YDH is similar to HDB. All kinds of different combinations would be acceptable there. Okay, last one here, home stretch. Number 13, what are the values of X and Y? So once again, just like the previous problem, let's go Papa, Mama, Baby. I'll stick with the same colors to be consistent. So here's the box for the purple Papa triangle. I'll redraw them just like I did for the previous problem. For sake of time, I'm not going to use a ruler to redraw these triangles. It's a little bit neater on my answer key on the website. All right, so here's the box. Now we don't have letters here, so now I got to figure out. I always start when I'm doing this kind of problem, I'm trying to solve for X and Y, start with the hypotenuse. Where's the hypotenuse? Well, here's the 90-degree angle. The hypotenuse is always opposite that side. Or if you think, you can think about this being like a little arrow. The arrow is pointing towards the opposite side. This whole length is the hypotenuse. So I got to add these numbers together. 36 plus 20, and that gives me 56 for the hypotenuse of the Papa triangle, for the big one. Okay, the short side, this is going to be the short side. Now this triangle is a little bit easier to see than that one. It's a little bit clearer that this is shorter than that is. Okay, so you don't have to, we don't necessarily have to put some numbers in here if we don't want to. The short side of Papa is going to be the X, okay, and then the long side of Papa down here on the bottom is going to be this long side. Okay, so the long side is going to be Y. Okay, so pause the video if you're getting confused on this, so you can make sure that you're orienting these triangles correctly. Short side X, long side Y, long side Y. Hypotenuse 50, hypotenuse 50, or excuse me, 56, hypotenuse 56. Okay, Mama triangle, the second biggest triangle. I will color code in blue. And here's the box. Here's the 90-degree angle for the blue Mama triangle. Okay. All right. Let's start with a hypotenuse. Okay. If you need to flip your paper, flip your paper. Okay. Here's the 90-degree angle. The hypotenuse is opposite. That's this side here. That's going to be the Y. Okay. So hypotenuse for Mama. Hypotenuse for Mama is Y. Okay, opposite the 90-degree angle. Okay, short side of Mama triangle, there's nothing there. So the short side, there's nothing there. The long side of Mama triangle is just this piece, which is 36. Okay, now it's time for baby triangle. Don't you love these beautiful orange and purple colors together? Beautiful stuff. Okay, so there's the orange triangle. Here's the orange box. Okay, all right, so let's draw baby triangle. There's 90-degree angle for baby. All right, let's start with the hypotenuse. Turn your paper if you need to. Looking at the orange triangle, here's the box. The hypotenuse across from that is going to be the X. Okay, where's the short side for baby triangle? Okay, short side is going to be this piece here. Okay, this is the short side of baby triangle, so that's going to be 20. The long side of baby triangle is going to be this piece down here, which is nothing. Okay. Once again, if you're not really sure about these angles, which one is shorter and longer, again, just like we did up here, plug some numbers in. Just plug in, make up a number to help you get oriented. Hopefully, you can see it on this one. Okay, now that we've got our triangles drawn and we've got our variables out here, we can now set up our proportions. To solve for x, which two triangles have x in them? There's an x here and there's an x here. So I need to set up a proportion for Papa triangle. I need to label these. Mama triangle, baby triangle. All right, so I need to set up a proportion that relates Papa triangle to baby triangle. I'm going to go left to right, so I'm going to say the short piece, x over 20. Okay. This piece over this little piece has got to be the same as the hypotenuse of the Papa triangle over the hypotenuse of the baby triangle. 56 over x. Okay. When I cross multiply, I get x squared is equal to 20 times 56 comes out to be 1120. Nobody cares what x squared is. I want x. So I got to take the square root of both sides. Guys, I'm fine if you want to leave your answer like this on the quiz, the square root of 1120. If you want to plug that in your calculator and get a decimal, that comes out to be 33.5. Either one of those is perfectly acceptable. Okay, 33.5. Okay, let's move on to y. Which two triangles have y in them? Papa has a y and Mama has a y. So I'm going to relate the purple triangle to the blue triangle. So once again, I'm going to go left. I'm going to go. This time I can't go left. I've got to go either go bottom to. I can either go bottom to top equals bottom to top, or I can go left to right. However you want to do it. Let's go left to right to be consistent. Y over 36. The long side of the Papa over the long side of the Mama has to be the same as the hypotenuse of the Papa over the hypotenuse of the Mama triangle. Y over 36 equals 56 over y. I can't reiterate this enough, guys. You're the boss. You could have gone bottom over top equals bottom over top. Y over 56 equals 36 over y. You still get the same answer. Cross multiply, y squared equals 2016. Couple of years ago. Again, you can leave your answers the square root of 2016, or that comes out to be 44.9. Okay, tricky stuff, guys. Chapter 6, Similarity. It's not the easiest stuff in the world, so if you're not understanding any of this stuff, please feel free to go back and rewatch parts of this video, slow it down, watch it as many times as you need to make sure you're comfortable with the concepts. Hope you guys enjoyed this video. We'll see you on the next one.